Hello, in this video I will do a short review on chapter 3, direct proof and proof by contrapositive. Alright, so what does mean direct proof, right? In the proof techniques, if you have some P and you want to get Q, so that basically can be written in the form P implies Q. If you can show, from P and then in between here you have different steps, so finally you get Q, that is a direct proof. What is proof by contrapositive? So we know that P implies Q is equivalent to Q, no Q implies no P. And since they are equivalent, sometimes instead of proving P implies Q, we prove that no Q implies no P. So in that situation, we call, that is contrapositive proof. Okay? So, we have to be very flexible to choose a method because, sometimes we can do direct proof, sometimes we need to do proof by contrapositive. Okay, let's consider the following example. Prove that n squared minus 3n plus 9 is odd for any n in Z. Alright, in this chapter we study some proofs involving integers, and we know that we have two kinds of integers, odd and evens, right? So let me do a very short review about that, and then we will start. So I will use like this, right? Review. So we have even integers. Even integers, is are of the form 2n, right? Where n is some integer. And we have odd integers. Now they are of the form 2n plus 1 for some integer n. So basically when it's very often when we need to do some stuff with integers, we need to consider two cases: when n is odd or n is even. Okay, so in this situation, we need to prove that n squared minus 3n plus 9 is odd for any n. So I would consider two cases. The first case, let me write the proof in here, right? So the first case, when n is odd, that means n is equal to 2k plus 1 for some k in Z. Then in this situation we will rewrite n squared minus 3n plus 9, right? We write n squared minus 3n plus 9 is equal to, you can write 2k plus 1 square minus 3k, and here I write 2k plus 1, right? Minus 2k plus 1, and then plus 9. So basically we can for this out, this guy square, and we use the one a plus b square equal to a square plus 2ab plus b square. If we use that, we have 4k square plus 4k plus 1 minus 6k minus 3 plus 9. And once we simplify -1 minus 3 and 9, and we group all terms of k together, so we have 4k square 4k minus 6k is minus 2k, and then 1 7, so I have plus 7, right? Plus 7. I want to show that, actually this integer, I want to show that this integer is of the form 2n plus 1. You know, so I have to rewrite this integer in the form 2, you know, k squared minus 2k, or let's say 4k squared minus 2k plus 6, and then plus 1. And then we take 2 out, we have 2k squared minus k plus 3 plus 1. So, you know, finally we already got the form 2n plus 1 in right here, right? So that is some kind of 2n plus 1. We finish that, you know, thus n squared minus 3n plus 9 is odd. Okay, this is very long proof, okay? This is very long proof, but you know, I just try to write very detailed. You might have a shorter one like this. A shorter one like this. So you can write, of course, in the case 1, right, where n is an odd. So if n is an odd one, if n is odd, then, you know, n squared and minus 3n are odd. Is it correct? You know, square of an odd is an odd. Minus 3, you know, 3 is an odd. Product of two odd numbers, two odd integers is an odd one. Hence, you know, n squared minus 3n is even, right? And now, you can write like you know, consequently, or you know, what happened with this? Consequently, you know, n squared minus 3n plus 9 is odd. Because 9 is odd, you know, sum of an even odd is an odd one. You know, this very short one. Of course, you know, you can choose, you know, either. I have no problem with that. The most important is, you know, you need to write a good proof, you know, and the proof should be logical and right. All right, let's consider the second case. You know, you can write case 2. Suppose that n is even, right? Suppose that n is even. Means, you know, n is equal to 2k for some integer k. All right, then we can rewrite. Then I don't have this in here, you know, we have to be very careful. Then n squared minus 3n plus 9 equal to 2k squared minus 3, 2k plus 9. So what's that? So, you know, we can write, yeah, that is, you know, 4k squared minus 6k plus 8 plus 1. I want to split, you know, 9 as 8 plus 1 because I want to group these three terms together. I have 2 times, you know, 2k squared minus 3k plus 4 equal to 1. So basically, you already have the form 2n plus 1. You see, where n is this number. And then, you know, therefore, n squared minus 3n plus 9 is odd. All right, so of course you can write another proof like this guy. So I will leave that to you, okay? And then, you know, since we consider 2 cases, we're already done with that. We, you know, close our proof. All right, next problem, example 2. You need to show that prove that if 3x plus 4y and 4x plus 5y are both even, then x and y are both even. So basically, what's that, right? You know, that means we have to show the implication P implies Q. I just, you know, just an observation. This is not the starting of the proof, where P is what? Where P is 3x plus 4y and 4x plus 5y are both even. And then your Q is, you know, oh, I should not write like this. I write like this, right? X and y are both even. So we need to show the implication P implies Q. All right, so, you know, we can do the following way, right? Now let's start our proof. Let's start our proof. You know, our purpose is to show x and y are both even. So basically, we have that, you know, 3x plus 4y and then 4x plus 5y are even, right? We can try to express x in terms of linear combination of 3x plus 4y and 4x plus 5y. And we'll see what happened with that, right? So I try to get a direct proof in this situation. Okay, I observed that, you know, 4x plus 5y in here, right? And then 3x plus 4y in here. So I can say, yeah, sorry, I want to eliminate x or y from these expressions. So I say, what happens if I want to eliminate, for example, x, right? So I have 3x in here, I have 4x in here. I can write, we have, no, even we don't need this, just we have, right? We don't need this guy. No, we have 4x plus 5y minus 3x plus 4y. You see, what is that? I want to eliminate x in here and x in here. You see that? So that's why I multiply by 3, and here I multiply by 4. And this is equal to, so here I have 3 with 5 is 15y minus 16y, which is negative y. You see, which is negative y. So what happened? This guy, we can write by assumption 4x plus 5y and 3x plus 4y are even. Since this guy is even, this guy is also even, you know, you multiply by 3 or 4 and you subtract them, you get an even number, right? By assumption, we have these are even. The left-hand side, no, I can denote line of star equation is even. Therefore, you know, negative y is even. Hence, y is even. You know, by doing so, we show that y is uneven. All right, next, we still need to show that x is an even, right? So let's say in this case we say we eliminate x. You know, you can do like you can eliminate y, right? But in this situation, I observe that, you know, in the first number 3x plus 4y, the second number 4x minus plus 5y. If I subtract, you know, to these numbers, I will get x plus y. You see that? So I can do the following way. I can write, yeah, let's have some connecting works, right? On the other hand, you know, we can write like this: 4x plus 5y minus 3x plus 4y is equal to x plus y. Again, by assumption, x plus y is an even. So, you know, I skip that by assumption 4x plus 5y and 3x plus 4y is an even, you know, are even. So I just go ahead, you know, by assumption we have that x plus y is an even because, you know, here difference of two even numbers is an even. So I say right where x plus y is an even. And then by the previous case, x is an even, right? Because we already have above, you know, we proved that y is an even. Sorry, it's y an even. So I can write y an even. Thus, x is also an even integer. So, you know, we close our proof in here. Okay, so, you know, in this case, even we also have a direct proof. We don't have, you know, proof by cases or, you know, counterparty proof. Let's consider another example, which is bonus, maybe on the quicks. So this example is, you know, problem 370 in the textbook. So that is page 103. Prove that for every positive integers a and b, no, a plus b times 1 over a plus 1 over b greater than or equal to 4. Okay, I just give you a hint, right, how to solve this problem. Because since this is bonus, you don't have to solve that. But, you know, I really hope that you can solve by yourself. So since we have product, you know, you can think that, yeah, let's for this out, right? Let's for this out. So I distribute this guy with this guy, this guy with this guy, this guy with this guy, with this guy with this guy. So I might have the following one. I say, yeah, that is 1. We have a plus b as 1 over a plus 1 over b is equal to a times, you know, 1 over a plus a times 1 over b plus b times 1 over a plus b times 1 over b. And this term, the first and the fourth terms are ones, right? So writing here just 1 plus a over b plus b over a plus 1, which is 2 plus a over b plus b over a. And we need to prove that this is, you know, greater than or equal to 4, right? We need to prove that this is greater than or equal to 4. So basically here we already have 2. So that means if we prove that a over b plus b over a greater than or equal to 2, So we add 2 to that. So we get this should be greater than or equal to 4. So that is our strategy. Okay. So let me erase this guy and say, yeah, if we can show this guy greater than or equal to 2, we are good. We're done. So we say let's okay, yeah, let's show that. A over B plus B over A greater than or equal to 2. So yeah, let's, since we have A over B, B over A, both are fraction, just let's cross multiply them. On the left hand side we have A squared plus B squared over AB, right? This is greater than or equal to 2. And then I will, multiply this, or we say multiply both sides by A times B. We get A squared plus B squared greater than or equal to AB. Then let's group them together. Let's bring this term, into another side, right? So you have A squared plus B squared. Oh, I write not plus B squared. I just, minus 2AB plus B squared greater than or equal to 0. Or this is A minus B squared greater than or equal to 0. So that means, what we are doing here, right? We show that this guy is equivalent to this guy. This guy is equivalent to this guy. This guy is equivalent to this guy. And this guy is equivalent to this guy. And this guy is what? This guy is tautology. And this, is true for any A and B, right? Say the last one, inequality is true for any A and B. Therefore, we can write here the second, 2 stars or 1 or second one. 2 star is true. 2 star is true, right? Since 2 star is true, since this guy is true already, you see, this guy is true. That implies that, this guy, when you add 2 to that, right? Consequently, we go back to this, we get A plus B, 1 over A plus 1 over B, greater than or equal to 2 plus 2, which is 4. So that is what we need to prove. Yeah, I hope that this video is useful for you and would help you to prepare to the quiz. Thank you for watching.